Hello everyone, my name is Jianji Chen. I'm glad to share our ICCV 2025 paper V2M4 4-dimensional animation reconstruction from a single molecular video. In the bottom right, you can scan the QR code to see more details of our paper. The motivation of our paper is that existing 4D animation reconstruction methods usually rely on multiple view generation prior, and this prior actually cannot provide certain 3D consistency. By the way, these methods usually rely on nerve or Gaussian splatting representation. This will additionally add difficulty in converting from these formats to mesh. Compared to them, our method focuses on using the current native 3D mesh generation method as a trellis of Human 3D. We think it is more promising to extend these native 3D methods to dynamic 4D. So this will allow us to directly produce animation assets that are readily usable in standard graphic pipelines like the Blender or the Unreal Engine. In the table here, we provide the details of the differences between our method compared to the previous 4D reconstruction methods. So in this paper, we present V2M4, a structured framework for 4D mesh animation reconstruction from only the monocular video input. In this paper, we address challenges like the pose ambiguity, geometric inconsistency, and textual misalignment. V2M4 actually comprises 5 key steps. The first one is the camera search and mesh reposing. This is to ensure the pose is aligned with the pose shown in the video frame. In the second step, we will refine the appearance of the mesh. This is to ensure it is aligned with the appearance displayed in the video frame. And in the third part, we will do a pairwise mesh registration. This is for geometry consistency among different video frames generating meshes. And in the fourth part, we will optimize a global textual map for textual continuity. And at last, we will do the interpolation and also convert the sequence of the 3D mesh to the 4D asset. Here will be provide some details for the first module, the camera search and mesh reposing. For this module, we aimed at estimating the camera pose. We first will sample a large number of the camera poses around the mesh, and then we will use the dense stereo prior at the dust3R to predict a coarse camera pose. Combining all these camera poses, we will then use the particle swarm optimization to get the best one. This is further followed by gradient-based refinement, which will further refine the camera pose. We here also mention more details for the consistent topology. To ensure that different frames can generate the mesh with the identical number of the vertices and the faces, we here take the first frame mesh as a rest pose, and we will register it to the following subsequent meshes. And the registration actually includes two parts, a global registration and also a local deformation refinement. So this process will ensure totally identical vertex and face topology across frames. You can see here the first, the third, and the fifth are the initial meshes, and the second and the fourth are the meshes after the registration. So you can see their number of the vertices and faces are the same. In this slide, we show the comparison results with the previous methods. In the left table, we can see our methods compared to the naive trellis and GMesh 4D have gained more benefit. We show almost or improved metrics. And in the right table, we show our method under different base models, like the Trellis, Craftsman 3D, SG, and Huiyan 3D 2.0. We can see the comparison compared to the naive ones. Our method at the most time will gain benefit. Here we show some visualization comparison. We can see that our methods can be well aligned to the input video. And here are more samples. Thank you for your watching. Please find more details in our paper on our project page.